In this tutorial, we will cover two chapters, Chapter 3 and Chapter 4, starting with Chapter 3, which is numerical measures. The learning objectives for this chapter, number 1 is to compute and interpret the mean, median, and mode. So we'll calculate 3 statistics for numerical data. Number 2, we will compute a weighted mean, and we do this if the data is given where each data value has a weight. We can compute the weighted mean. Number 3 will not be covered. Anything in red is not covered in this course. Next will be number 4, compute and interpret the range, variance, and standard of deviation. And these are measures of dispersion. Number 6, compute the mean and standard of deviation of group data. A measure of location is a value used to describe the central tendency of a set of data. These measures are calculated for a set of data, and they would give us generally an idea of the data that we are looking at, and where most of the data tends to be. The 3 measures that we will cover are the mean, median, and mode. And the mean being the most widely used measure of location. There's طبعا you have to distinguish between the population mean and the sample mean. If we have data from a population, we can measure the population mean. We use the letter mu to designate the population mean. This is the sum of all data values, the sum of x divided by n. The sum of all data values divided by the number of data values that we have. This is, of course, is a measurable characteristic of a population. Any measurable characteristic of a population is a parameter, and certainly the mean is one of the parameters we calculate for a population. Here is an example of calculating the population mean. The data in this table represent there are 42 exits in I-75. This is a highway in the state of Kentucky. What's listed in the table are the distances between exits in miles. Why is this information as a population? Well, that's the same data. This is a population because we're considering all the exits in Kentucky. So our data now represent numbers, which are the distances between exits in Kentucky. To calculate the mean number of miles between exits, just apply the definition. Mu is the sum of x divided by n. So we add all the values, divide by 42 because n is equal to 42. The number of data values is equal to 42. The sum is 192. We divide that by 42. The result is 4.57. The units here should be miles. Then the mean number of miles between exits is equal to 4.57 miles. For a sample mean, this is when we are working with a sample. The sample mean, we use x bar for to designate the sample mean. It's defined like the population mean. You take the sum of all data values divided by small n this time by the number of data values in the sample. This is, of course, something that would describe a sample. It's a characteristic of a sample. Here is an example of a sample mean. Verizon, which is a mobile company, is studying the number of minutes used by clients in a particular cell phone rate plan. A random sample of 12 clients showed up the following number of minutes used last month. There's 12 clients in the sample, so we have 12 data values. Each data value represents how long a client used that particular phone plan. طبعا this is information from a sample. يعني the result will be a sample for the يعني the mean for the sample. We want to calculate the arithmetic mean number of minutes used. طبعا we take the sum of all values divided by the number of values in the sample. The sum of all data values come to 1170 divided by 12, which is the number of values, come to 97.5 minutes. The mean number of minutes used is 97.5 minutes. Some of the properties of the arithmetic mean. You need interval or ratio scale of measurements to calculate the arithmetic mean. It is also clear that all data values are used in the calculation. It is unique for a set of data. If you look at the sum of deviation from the mean, طبعا the deviation from the mean, that means you subtract the mean from each data value. The different, if you take x minus the mean, that's the deviation. That could be, of course, positive or negative or 0. The sum of all deviations from the mean will equal to 0. One of the weaknesses of using the mean is that it's affected by extreme values. If you have a very large value or a very small value, that will affect the mean. The next statistic is the median. طبعا from the name here, it is the middle value for the data after it is sorted. The definition here, the median is the midpoint of the values, the middle value of the data after the data have been ordered from minimum to maximum. طبعا it will work if you sort it from maximum to minimum, but normally we sort the data from the minimum value to the maximum value. Here is an example. We have 5 data values in dollars. They represent something. The 5 data values are sorted in the left column from the smallest to the largest. There are 5 values. So the third value, 70,000, is the median. طبعا this is the middle value because there is 2 values below it and there is 2 values above it. طبعا you get the same result if you sort it from maximum to minimum, but normally it is sorted from minimum to maximum. Look at the properties of the median. The median is the value in the middle of a set of ordered data, and it has to be sorted. At least the ordinal scale of measurements is required. It is not influenced by extreme values because it's a position of the middle value, so it's not influenced by extreme values. 50% of the observations are larger than the median, and of course 50% of the observations will be less than the median. It is also unique to a set of data. Now, the example we looked at, we had 5 data values, so there was a middle value. One of the data values is in the middle, that was the median. In the case, if you have an even number of data in the set, طبعا you no longer have a middle value, you have 2 middle values. So what we need to do is take the average of the 2 middle values. So you still have to sort the data if you have an even number of data values. But in this case, you have 2 middle values. You have to take the average of the 2 middle values, meaning add the 2 numbers and divide them by 2. Here is an example. This is the number of hours a sample of 10 adults used Facebook last month. طبعا here this is a sample that has 10 people, so you will have 10 data values. Each of these represent how long a person used Facebook last month. طبعا always remember to sort the data before you decide what the median is. That's always is your first step. Arrange the data in ascending order, and here is the same set ordered from the smallest to the largest. Now with 10 data values, the first middle value will be 10 divided by 2, so it's value number 5 is the first one, and then the next one, which is the sixth value, will be the next number in the middle. So the two numbers in the middle are the sixth and seventh value. It is the fifth and sixth value. Take 5 plus 7, that's 12, divide by 2, and that will give you the middle value. In this case, the median will be 6. Just 5 plus 7 divided by 2 is equal to 6. The mode is the value of the observation that occurs most frequently. طبعا if you happen to have a bar graph, then the mode is the class with the highest frequency. In this graph here, the mode is this rectangle, the more that has the highest frequency, so this represents the mode. But of course, if you have a set of data, one thing, if you do order the data, then you can tell the data values that are repeated. You want to select the values that occur most frequently. Some of the characteristics of the mode can be found for nominal level data. A set of data can have more than one mode, as we will see. You may find, for example, that in a set of data that one value is repeated 3 times, and that's the maximum number of repetition. But now any number that's repeated 3 times will also be a mode. It is possible to have more than one mode. If all the data values are distinct and no repetition, then there is actually no mode. A set of data can have more than one mode, or it can have no mode. The relative position of mean, median, and mode can tell us something about the distribution of the data. But we have 3 situations here. The graph to the left, you have the mean equal the median equals the mode. We say that this is a symmetric distribution. If you look at the graph of the distribution, if you look at the vertical line going through the peak, it splits the graph into 2 equal halves. And that usually happens if the mean equals the median equal the mode. The graph in the middle, in this distribution, the mode is less than the median, and the median is less than the mean. You notice that the peak shifted to the left, and the small values are more to the right. You have a tail to the right. You say that the distribution here is positively skewed or skewed to the right. The graph to the right, the peak is shifting to the right, but the small data or the tail is to the left. Here the mean is less than the median, less than the mode. In this case we say that it is negatively skewed or skewed to the left. The 3 statistics we have calculated so far, the mean, median, and mode, if you compare those values where they are located, that can give you an idea what the shape of the distribution is. طبعا we'll talk about skewness of graphs or distributions in more details later in this chapter. Here is an example about calculating a weighted mean, and that happens if you have data that's given with weights assigned to each data value. The weighted mean is found by multiplying each observation by its corresponding weight. And here is the formula for the weighted mean. X bar, and we write W, sub W, to indicate this is a weighted mean. For the numerator, we take each data value, multiply it by its weight, add all those products, and divide by the total of the weight, the sum of the weights. And here is an example. The Carter Construction Company pays its hourly employees. There's 3 different wages. $16.50. The second one is $19. The third rate is $25. These are the data values we are trying to calculate the weighted mean 4. These طبعا the weights are the number of employees that are paid each rate. يعني for 16 for the first rate 16.50 there are 14 employees that are paid that rate. So this is the weight for the first data value. 14 is the first weight. The second rate, $19, there are 10 employees that are paid at that rate, so the weight for it is 10. The third rate, $25, there are 2 employees paid at that rate, so this is the weight for the third data value. What is the mean? Here it will be a weighted mean. We want to calculate the mean hourly rate paid for the 26 employees. This is a weighted mean. Take each data value and multiply it by its weight. Add all those products. Divide by the sum of the weights. The sum of the weights here now is 14 plus 10 plus 2, which is equal to 26. The total of the products is $471 divided by 26, which is the sum of the weights. The result will be 18.1154. This could be rounded to 18.12. That represent the mean hourly rate. طبعا it's a weighted mean because we used weights that were assigned for each data value. The next set of measurements is to calculate the dispersion or the variations or the spread of a set of data. يعني many times يعني the mean of course or the mode or the median doesn't tell you if the data is spread out or if it is يعني concentrated maybe near the median or the mode or the mean. Dispersion can be measured for a set of data. We will look at 3 different measurements that you can calculate to calculate variation or dispersion. The first one is called the range. This is just the difference between the maximum and the minimum value in the set of data. Here is the formula for the range. The range is just the maximum value minus the minimum value. طبعا if the data is already sorted, the first value will be the minimum, the last value will be the maximum. If you take the maximum minus the minimum, that is just the range. The major characteristics of the range are only 2 values are used in the calculation. That's the maximum and the minimum. It is influenced by extreme values. طبعا if the maximum is very large or if the minimum is very small, that will influence the value of the range. Of course it is easy to compute. It's just the difference of 2 numbers. It is easy to compute and to understand. The next measure that we will calculate is the variance, and طبعا that can be calculated for a population or for a sample, but the formula for the population is slightly different than the formula for the sample. Starting with the population variance, we use sigma squared for the variance of the population. This is the sum of x minus mu squared divided by n. This sum on top is the sum of the square of the deviations divided by n. The deviations, just to remind you, is calculated. Take every data value, subtract the mean, then square the deviation, take the sum of the square of deviations and divide it by n, which is the number of data values. طبعا it's very clear to calculate the variance you need to know what the mean is. So normally the first step to calculate the variance is you should calculate the mean. We look at the characteristics of the variance, that for one thing all observations are used in the calculation, but the units are somewhat difficult to work with because they are the original units are squared. The units for the variance will be the square of the original units. Now for a sample, the formula for calculating the sample variance is slightly different. The sample variance, we use S squared to refer to the sample variance. It is the sum of x minus x bar squared divided now by n minus 1, where n is the number of observation. So here you take the sum of the square of deviations from the mean divided by n minus 1, where n is the number of observations. Here is an example of calculating the sample variance. The data that we have represent the hourly wages for a sample of 5 part-time employees at Home Depot. There are 5 employees, so there's 5 values: $12, $20, $16, $18, and $19. We can include this. The best way to calculate the variance is use a table. In the first column, we list the data values. You need the sum of those data values, because from that sum, if you divide by n, in this case it's 5, that will give you the sample mean, which is $17. You need the mean to calculate the variance. Now, to calculate the variance, use the same table. The second column, now you calculate the deviations by subtracting the mean from each data value. Some of the data values will be negative, some of them will be positive, but the sum of deviations will always be 0. In the next column, you square each deviation and then add the sum of the square of deviations is added. In this example, it's equal to 40. Once you complete the table, you are very close to finding the variance for the sample. S squared is the sum of the square of the deviation, which you already calculated in the table, equal to 40, divided by n minus 1. N is equal to 5, so we're dividing by 5 minus 1. 40 divided by 4 is equal to 10. The variance for this set is equal to $10 squared. The next measure, and that's the measure we'll use most of the time, is called the standard of deviation. For the sample standard of deviation, now we use S, is the square root of the sum of the square of deviations divided by n minus 1. You notice the quantity under the square root is just the variance. The standard of deviation is just the square of the variance. You can, if you want to calculate the standard of deviation, you can apply the formula directly, or you can calculate the variance first and then take the positive square root of the variance, and that should give you the standard of deviation. The population standard of deviation is calculated similarly. It's just the square root of the variance of the population. What do we know about the standard of deviation? It is in the same units as the original data, because you are taking the square root of the variance, so you end up the units will be the same as the original data. It is the square root of the average squared distance from the mean. You are taking here the distance of the mean is the deviation. You're squaring that. You're adding the square of all deviation divided by n minus 1, so you can think of it as the square root of the average squared distance from the mean. You're taking the square root of the variance. It cannot be negative because we take the positive square root of the variance. And it is certainly the most widely used measure of dispersion. Now for group data, remember group data, like the example we did in the last tutorial, here the data is divided into classes, and the frequency of each class represent how many data values are in each class. For that type of data, for each class, you already have the frequency recorded. You also need to calculate the midpoint of each class, And then in this case, the arithmetic mean for group data is calculated this way. Now this is for a sample. So this is x bar. It is equal to the sum of f times m, f being the frequency and m is the midpoint, divided by n. Yani take the product of the midpoint of each class is multiplied by the frequency, you add all those products and divide by n. فطبعا your group data is normally is listed in a table, you can do the calculation you need, the midpoint for each class, and then apply this formula to calculate the mean. And we will do an example where the mean is calculated for group data, and also we'll see how to calculate the variance and the standard of deviation for group data. Here is the data that we used for from the previous example. That was the data for the Applewood Auto Group. If you remember, they sold 180 cars, and we had the profits from these cars. We made a distribution for that. We did a table where we summarized the data. The data was divided into 8 different classes. The frequency for each class was listed. This is the second column. The frequency tells us how many data values are in each class. It is listed in the second column. The sum of frequency is 180 because we had 180 cars. Next, you want to calculate the midpoint for each class because it's used in the calculations of both the mean and the variance. The midpoint is calculated for each class, and we did this last time. Next column, you want to multiply, for each class, multiply the frequency by the midpoint. This is listed under the column. F times m is just the frequency of each class times the midpoint. What you also want to do is calculate the sum of all these products, because this sum now, if you divide it by the sum of frequencies, that should give you the mean for that set of data. Before we continue, you need to calculate that value, divide the sum of f times m, the frequency times the midpoint. It will come to 333,200. Divide that by 180. That should give you the mean for the set of group data. Next, now we continue so we can calculate the variance and then the standard of deviation. The next column we need is to calculate the deviation. This is the deviation of each midpoint, because each midpoint of a class represents all the values in the class. So what you want to do is calculate the deviation of each midpoint from the mean. These values are just for each class. Take the midpoint minus the mean, which we already calculated in the previous step. Again, these are deviations from the mean. Some of the values will be negative and some of them will be positive. In the next column, you want to square the deviation for each class. And then in the final column, you want to multiply the frequency times the square of the deviation. Because those quantities, when they're added, that will give you, you're almost will have the variance. This last column, one more time, this last column, you just multiply the frequency for each class times the square of the deviation, which you calculated in the previous column. You need the sum of all those products. In this case, it will be 76,169,780. That quantity, if you divide it by n minus 1, this is a sample. If you divide it by n minus 1, that will give you the variance. If you take the square root of that, that will give you the standard of deviation. The standard of deviation for this set, S, is the square root of the sum of the square the square of the deviations times the frequency. This is for each class. Take the sum of all those products. طبعا this is already calculated in the table. Divide this by n minus 1. In our case, n is 180. The result of this calculation will give you the standard of deviation. This is $652.33 and 33 cents. The units here should be dollars. This is the steps that you have to do. طبعا we did both. We calculated the mean for the group data, and we also calculated the standard deviation. If you need the variance, طبعا if you already calculated the standard deviation, then square that quantity. That will give you the variance. And one option that you have is calculate the variance first and then take the positive square root. The result will give you the standard of deviation. The last slide in this chapter, as usual, will be ethics. طبعا ethics associated with reporting results. طبعا we discussed some of advantages and disadvantages of the mean, median, and mode. You need to take those into account when you're reporting statistics, as we use statistics to make decisions. طبعا as we mentioned before, whenever you use statistics, you need to maintain an independent and principled point of view. Statistical reporting requires objective and honest communication of any result. Now we're ready to start the next chapter. The next chapter we will discuss graphs, how to display data using different graphs. We already looked at examples of graphs. In this chapter we will look at more graphs. Here are the objectives. Number one, we want to construct and interpret a dot plot. This is one form of graphs that we use. Next, we want to construct and describe a stem and leaf display. This is not really a graph, it's more like a table we use to display data. Number three, we want to identify and compute measure of position. We already have one measure of position, which is the median, but we want to see how we can calculate and identify other measures of position. Next, we want to construct and analyze a box plot. This is another type that we use when we are working with statistics. Next, we discussed skewness in the previous chapter. In this chapter, we want to measure, we want to compute a measure that will tell us about skewness. This is what we will do in this chapter. Next, we will do another type of graph called scatter diagram or scatter plot, and that's used to actually see if there is a relationship between two different variables. And the last thing we will do, we'll look at an example of a contingency table. Contingency tables are used to display data, and also we will use them in the next chapter. When we discuss probability theory, contingency table can be used to calculate probabilities. First, we will look at dot plots, and these are used to compare two different sets of data. Here are examples. We have two different sets of data. These represent the number of vehicles serviced last month in two different locations, two different dealerships. The top table record the number of cars that was serviced in Tainusta. The data is for 1 month. There's this is you have a 6-day in the week, work week. This data represent the number of cars serviced during that month for the first location, which is Tainusta. The table below is the data for a second location. In this case it's Sheffield, and it's also the number of cars serviced for 1 month. Our dot plot will compare the two different locations. Here is a picture of a dot plot. The one we're looking at is made by Minitab. Minitab is software that's used in statistics. This given example here is done by Minitab. When you see the columns to the left, there is two columns, C1 and C2. The first column includes the data from the first location, Tainusta. C2 includes the data for the second location, Sheffield. For the graph, you have two parts. The first part is the dot plot. You have a line for each location. You have a scale, some kind of scale that will tell you the number of cars. Each location has its own line, and you have and you can compare the two groups, the number of cars serviced for the month in the two different locations. What's also useful for this particular example, Minitab will also give you a summary statistics. It is descriptive statistics, so it's summary statistics for the both locations. And this is another way to compare the two locations, is by comparing the two different statistics. We have two lines, one for Tainusta, the top one, and one for Sheffield, which is the lower line or row. One thing is recorded here is the number of observation. It is 24 for both locations. Also, the mean for each location is listed, so you can compare that. And for this example, the mean number of cars serviced for Tainusta is 31.292. For Sheffield, it is 35.83. It also lists the standard error, which we have not covered that yet. The standard of deviation is listed for both locations. The minimum value, Q1, which is the lower quartile. The median, for example, the median for the Tainusta location is 32. For Sheffield, it is 36. Q3 is listed for both locations, and the maximum value is also listed. You can also compare the two locations by comparing the relevant statistics from both locations. Next, we'll look at a stem and leaf display. This is an alternative to frequency distribution and a histogram. The advantages of the stem and leaf display, that you can identify each observation, every observation is shown in the display. It's not lost. The digits themselves, we use the digits themselves give a picture of the distribution, and this will become more clear as we see an example of a stem and leaf display. The cumulative frequencies are also shown. Let's start with the definition of stem and leaf display, and then we will go to the next slide and look at an example. The stem and leaf display is a statistical technique to present a set of data. Each numerical value is divided into two parts. The leading digit becomes the stem, and the trailing digits become the leaf. The stem is located along the vertical axis. You can list the stems, and for each stem you can list all the leaves. Many of the numbers will have the same leading digits, so they will share the same stem. You can list the stems in a vertical axis, and then for each stem you can list all the leaves in the horizontal axis. You can list them stacked against each other along the horizontal axis. Let's look at an example of a stem and leaf display. First of all, the data we're working with represent the number of people attending each of the 45 performances at the Theater of the Republic. So this is a theater. They keep records of the attendance of the different performances. We have 45 performances, so there's 45 data values. Each represent the number of people attending at a different performance. So here are the different data values. We need to check each value. We will take the first digit to be the stem, the leading digits to be the stem. طبعا يعني the leading digits you may take the make يعني have double digits, but the leading digits will be the stem. And then طبعا once we pick a stem, we can list all the يعني leaves. They may have more than one number that have the same leading digits or the same stem. You list the stem one time, and then all the leaves in the horizontal axis. So here is the display for this given set of data. Here is طبعا look at the left display. Here are the different stems. طبعا they are listed in an increasing order. 8, 9, 10, 11, 12, 13, 14, 15. Those represent the stems. These are the leading digits. For example, for the stem 8, there is 2 leaves, 8 and 9. For the original data, you will see 88 and 89. These are 2 of the data values. For the stem, which is 9, there is several leaves. طبعا each leaf will represent different data values. For example, you'll have 96, 93, 95, 96 again, 94, 94, and 97. يعني all of these data values are in the original set. يعني this is how you organize the data, and this is called the stem and leaf display. The display to the right is exactly the same one, with the leaves now organized or sorted in increasing order. This is exactly the same display. The only difference here is that the leaves are sorted or displayed in increasing order. Now we're ready to calculate measures of position. طبعا we already looked at the median, which is a measure of position. The median gives you 50% of the data. Yani once you locate the median, you know 50% of the data is less than the median and 50% is more than the median. But we need to specify other locations. Starting with the طبعا measures of location also describe the shape of the distribution and can be expressed as percentiles. Here is the formula to find the location of the percentile. Think of the median now as the 50th percentile. This gives you the middle value. It is the middle value. But طبعا there are other percentiles. Here is the formula. LP, L stands for location and P is percentile. It is n plus 1 times P over 100. طبعا n is the number of data values and P is the percentile we are trying to locate. For example, the median is the 50th percentile, so it's L50. It is equal to n plus 1 times 50 over 100. But also we'll look at quartiles. If quartiles divide the set of observation into 4 equal parts. You can look at the first quartile, Q1, this is L25. So it is n plus 1 times 25 over 100. The median itself can be considered to be the second quartile. So this is L50 or n plus 1 times 50 over 100. The third quartile, or some books call it the upper quartile, is the 75 percentile. So you can calculate it. Q3 is calculated by using 75 for the percentile. It will equal to n plus 1 times 75 over 100. طبعا once you calculate the quartiles, if you think of the median as the second quartile, the quartiles will divide the set of observation into 4 equal parts. Each part is 25% of the data. The interquartile range is just the difference between the third and first quartile. Take Q3 minus Q1, that will give you the distance between the first and third quartile. This is called the interquartile range. So you can think of this as another measure of dispersion. Deciles divide the set of observation into 10 equal parts. You can even go smaller than that. You can calculate percentiles. This percentile divide a set of observation into 100 equal parts. Normally you don't do that for a small set, but if you have a large set, for example, if you're looking at the grades of all students in one course, this might be a large set, so percentiles or dividing the set into 100 different parts will make sense. Now we're ready to do some calculations. Here's an example of calculating different locations, different percentiles. This is data from Morgan Stanley. This is a big investment company in the United States. They have offices located throughout the United States. What we have here in the list is commissions earned last month by a sample of 15 brokers. So we have 15 data values. The data here is not sorted, so the first thing to do is to sort the data from the smallest to the largest. And here is the list, same list, sorted. With the first value, the smallest value, 1,460. That's the smallest commission. And the largest value, the maximum, is $2,406. That's the largest commission. First, let's find the median, which is the 50th percentile, L50. N plus 1, n is 15, so take 15 plus 1 times 50 divided by 100. This is 8. What this tells me, the location of the median is in the 8th position. The median is the 8th value of our list, our sorted list. Go back to your sorted list and find the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. The 8th value is $2,038. This represents the median. And if you notice, the median here, you get the same value as you used the old method that we used. There's 15 data values. The middle value is the 8th value. There are 7 values below the median, and there's 7 values above the median. Next, we would like to calculate Q1, the lower quartile, and the upper quartile. Starting with the lower quartile, this is L25. We take 15 plus 1, which is m plus 1, times 25 over 100, and this is equal to 4. So the lower quartile is the 4th value, 1, 2, 3, 4. The lower quartile, Q1, is 1,721. The upper quartile, Q3, is L75. The position, the location, is 15 plus 1 times 75 over 100. This is equal to 12. The upper quartile, or Q3, is in the 12th position. If you count, the median was the 8th position, 9, 10, 11, 12. Then Q3, the upper quartile, is 2,205. Okay, in the previous example, the location where the numbers we came up with were whole numbers, so it was easy to locate the position. But the formula that we use, sometimes we end up with a number that's not a whole number, a fraction. Let's see how we can handle that. Here is a set of data that has 6 values. We would like to locate the first quartile, Q1. First step, as usual, we sort the data. The first value will be 43, and the last value will be 104. The first quartile is located at, using our formula, this is L25, 6 plus 1 times 25 over 100, this will be 1.75. Now this is a location. 1.75 is between 1 and 2, so our first quartile will be between the first and second value, data value. The way to do this, we need to take x1 and then take 0.75 of the distance between x1 and x2, and that's what we will do in the next slide. طبعا just to explain some more about what we're doing, the position formula tells us that the result was 1.75. The first quartile will be between first and second value. It is 0.75 of the distance between the first and second value. Let's write it as an equation. Q1 is just x 1.75, and it's located at 1.75. This is x1 plus 0.75 of the distance between x1 and x2, and that's just x2 minus x1. X1 is 43 plus 0.75, x2 is 61 minus x1, which is just 43. If you do this calculation, you should get 56.5, and that is Q1. That is the lower quartile. Next, we would like to look at box plots, and these are graphical displays. What we use them for is to list 5 different statistics. It is actually a summary of the 5 statistics, including starting with the minimum value, first quartile, the median, third quartile, and the maximum value. So basically that would just summarize both the minimum and maximum values, Q1 and Q3, and the median. Of course, if you have all these values, you can measure the interquartile range by taking Q3 minus Q1. Also, when you do a box plot, you can list the outliers. The outliers are values that are inconsistent with the rest of the data. They could be either very large or too large than most of the data, or too small. These are called outliers, and they are identified with asterisks in the box. They are included in the box. Let's look at an example. This is Alexander Pizza offers free delivery for its pizzas within 15 miles. How long does a typical delivery take? Different deliveries take different times depending on the distance. So we want to know how long does a typical delivery can take. Within what range will most deliveries be completed? And here, if we can calculate the interquartile range, that might give us at least half of the deliveries are made within that range. What we would like to do is construct a box plot and summarize the different statistics that we can calculate for the set of data. Here the set of data will be different times, different deliveries. So we have a sample of 20 deliveries, the time it takes for 20 deliveries. The owner of the place did all the calculations for us. So you find that the minimum value is 13 minutes, Q1 is 15 minutes, the median is 18, Q3 is 22, and the maximum value is 30 minutes. We would like to develop a box plot for the delivery times. Here is the picture of the box plot. You need to start with a scale that is appropriate for the data, and it covers all the data. Starting with the box, you need to first mark the values for Q1 and Q3. Your box will start at Q1 and ends with Q3. The next thing, you want to locate the median, and you can draw a line inside the box that represents the median. The median will be between Q1 and Q3. The location of the median depends on the data that you have. It could be more to the right, or it could be to the left, or it could be in the middle, depending on the data. Next, you want to locate the maximum value and draw a line. This broken line is drawn from the right side of the box, from Q3 to the maximum value. This right this line is called the right whisker. Finally, you need to draw the left whisker, and you locate the minimum value and then draw a line from the minimum value to the box. This is called the left whisker. In this graph, طبعا, the right whisker is longer than the left whisker. But this is for this set of data. يعني you may have both whiskers are equal, or you may have the left whisker longer than the right whisker. This is all يعني depends on the data that you work with. طبعا an additional thing that's not done here is that you can write the values for these different statistics. يعني you can write the minimum value Q1, the median Q3, and the maximum value. You can write them on the graph itself. That will make them easier to read from the graph. Here is يعني the box plot for the data that we have. Box plots are used يعني to summarize the 5 statistics, and also they can be used to compare 2 different sets of data. And if you are comparing 2 sets, you can draw a box plot for each set and compare the different values, the different statistics from the 2 different sets. The last thing we will do in this chapter is we will يعني go back to the idea of skewness, the يعني general shape of the distribution. We already looked at the 3 cases. If the case where we consider the graph to be symmetric is where the mean equals the median. Here the graph is symmetric about the line in the middle. يعني look at the peak. The vertical line through the peak splits the graph into 2 equal parts. This is called symmetric graph, and in this case the mean is equal to the median. The next graph here, we say it is positively skewed or skewed to the right. Here the peak, the highest value, is more to the left, and you have a long tail representing the smaller values. In this type of graph, you will see that the median is less than the mean, and we say that this is positively skewed or skewed to the right. The next graph, the peak here, the highest value, is more to the right. The tail, the long tail, is to the left. This is we say that this graph is negatively skewed or skewed to the left. Here you notice the mean is smaller than the median. The fourth type, the bimodal, we will not consider graphs of this form. We will basically look at graphs that are either symmetric or positively skewed or negatively skewed. طبعا يعني one way to do this, as we have seen, is comparing the mean and the median and the mode. The other way, which we will do now, is we will decide on the shape of the distribution or the skewness by calculating the coefficient of skewness. This is a measure of the symmetry of the distribution, whether it's symmetric or skewed one way or another. Here is the formula for calculating the skewness measure, or the skewness measure here is the Pearson's coefficient of skewness. We use SK to represent the coefficient. The formula is that you take 3 times x bar minus the median. I take 3 times the mean minus the median divided by the standard of deviation. So you need 3 statistics to measure the skewness: the mean, median, and standard of deviation. The value of this coefficient will be a number between -3 and +3. طبعا clearly if you have a negative value, the graph is skewed to the left, طبعا to varying degrees. If you get a positive number, then the graph is skewed to the right. If you get 0, then the graph is symmetric. A value near -3 indicates considerable negative skewness. If you get a number like 1.63, then you have positive skewness, but it is moderate. Since this is not close to 3, 1.63 represent moderate positive skewness. If you get 0, then that tells you the distribution is symmetric. Let's apply this to a set of data and try to decide on the shape of the distribution. The data in this table represent earnings per share for a sample of 15 software companies for the year 2016. طبعا 15 companies, that means there is 15 data values. Each value represent the earnings per share for one company. These are arranged from the smallest to the largest. We don't have to sort them. Each number represents the earnings per share for 15 different companies. So here n is equal to 15. We have 15 data values. The smallest data value is the first one, $0.09. The maximum is $16.4. We would like to طبعا calculate the skewness measure or coefficient. So we need to calculate the mean, median, and standard of deviation to find the coefficient of skewness. Once we have this number, we can decide the shape of the distribution, whether it's symmetric or left, negatively skewed or positively skewed. This will take some calculations, starting with the mean, x bar. This is the sum of all values divided by n. The sum will be 74.26. Divide this by 15, which is the number of values. You should get 4.95. This is the mean. Next, we want to do the standard of deviation using the formula. S is the square root of the sum of the square of deviations divided by n minus 1. طبعا you can either use a table or do it in one line. You should get طبعا the square root of this quantity. You need a calculator probably for that. You should get 5.22. That is the standard of deviation. Next, we want the median. If the data is already sorted, you'll find that the median is equal to 3.18. Now we are ready to calculate the measure of skewness. Sk is equal to 3 times x bar minus the median divided by the standard of deviation. For our example, this is 3 times 4.95 minus 3.18 divided by 5.22. This should get 1.017. This is our measure of skewness. طبعا it is positive. The data or the distribution is skewed to the right, but this is not close to 3, so we can conclude now we have moderate skewness to the right. We do have one more diagram to look at. I forgot about the scatter diagram or scatter plot. This is used to describe the relationship between two variables. A scatter diagram is a graphical tool to portray the relationship between two variables or bivariate data. This is paired data. It's reported in pairs. One is for the first variable and the second value is for the second variable. So you can actually plot them as points, and the plot is called a scatter diagram. Both variables are measured with interval or ratio level scale. If the scatter plot of points moves from the lower left to the upper right, as you move from left to right, the graph rises. The variables under consideration are directly or positively related. One variable increase, the other one will increase. If the scatter of points moves from the upper left to the lower right, that means as one variable increase, the other one decrease. This is an inverse relation or negative relation, and we will see this in the example. We have three different sets of data. The first set of data, the scatter plot for that. This is the two variables deals with buses. We want to see if there is a relationship between the age of a bus and how much it costs to maintain. طبعا يعني it is reasonable to expect that the older the bus is, the more money it will cost to maintain. If we look at the data here, each point, طبعا these are points. The horizontal direction represent the age of the bus in years. The vertical axis represent the cost. For each point, the coordinates, the first value gives you the age of the bus and the cost of the maintenance for that same bus. So you can see the dots here are increasing, يعني as you move from left to right, as the age of the bus increase, so does the graph rises, so the cost of maintenance also rises. So this is a positive relationship. That means you have a direct relationship. As one variable increase, the other one also increase. The second graph in the middle, it looks like an inverse relation or a negative relation. This is the two variables. طبعا this deals with used cars when they're sold at auction. The odometer tells you how many miles the cars have been driven. But طبعا the higher the odometer is, that means the car is used more. The price of the car at an auction will be less. طبعا if the odometer is low, that means the car was not used much. It will get you a higher price. This is an inverse relationship. If you look at the graph, as you move from left to right, the graph drops. That means the higher the odometer reading, the less the auction price will be. So this is an inverse relationship or a negative relationship for this example. طبعا a scatter plot doesn't always tell you one relation or another. It is possible that there is no relation, or at least the scatter plot doesn't show you that relationship. And this is the third example. The third example shows the relationship in the two variables is the height of a person and how much money they make, the salary of that person. Is there a relationship between the height of a person and how much money he makes? طبعا logically no, you expect that there should be no relationship. The scatter plot, you see points scattered everywhere. There is no positive or negative relationship. You can conclude from this graph that there is no relationship between the height of a person and how much money they make. We have looked at the final graph for this chapter, but we still have one more thing to cover, which is contingency table. We'll just look at an example of a contingency table, and we will use contingency table in the next chapter. A contingency table is used to classify nominal scale observations according to two characteristics. And here's the definition, which says the same thing. A contingency table is used to classify observation according to two identifiable characteristics. You can think of it as cross tabulations that simultaneously summarizes two variables of interest. We will see طبعا what that means in the example. Both variables need to be only nominal or ordinal. Here is my contingency table, and it is the same example we started with. It is for the Applewood Auto Group profit comparison. You have the different locations. We started by comparing the number of cars sold at different locations. Now we're interested in the profit, so we want to compare the performance of the different locations when it comes to profit. So we had 180 cars, and here is the different locations, and each location has a column. we look at each location. For example, Kane, we want to see the number of cars they sold, how many they sold were for a price above the median price, and how many were sold for less than the median price. For example, Kane sold 52 cars, 25 of them were above the median price, and 27 are higher than the median price, for a total of 52 cars. Olaine sold 40 cars, half of them above the median and half of them are above. Sheffield sold 45 cars, 19 were above the median and 26 were below. Finally, Tainusta sold 43 cars, 26 of them for above, for a profit above the median, and 17 for a price below the median. طبعا the total will be 180, 90 were sold above the median and 90 were sold below the median. Now if you compare percentages, that will give you a comparison between the different locations as far as the profit is concerned. Here are the percentage of profits above the median for the different location. For Kane it is 48%, for Olaine it's 50%, Sheffield 42%, and Tainusta 60%. فيو notice even though Kane sold more cars than any other car, it does not have the highest profit. The highest profit was at Tainusta. They sold 60% of their sales were for prices above the median. The idea of this table is just to give you an idea what the contingency table. Here we used it to compare the performance of the different locations as far as the profit is concerned. طبعا you can also use it, the same table is to compare the number of cars, the performance as far as the number of cars. You can have a larger table, you can list more characteristics. We will see more examples in the next chapter.